folks to settle in. All right, I think I see the folks joining in. I guess I think we can start. All right. Hello and good morning, everyone, to our session, or good afternoon, good evening for the folks joining in from across the Atlantic and beyond. Uh, Thank you once again for taking the time out from your schedules to attend this webinar. I'm Midun, and I take care of marketing for Applied Systems Engineering ASE Calcitech. ASE has always been an advocate of open standards and standard-based communications to facilitate interoperability in the true sense. Today's topic is on how to simulate and monitor sample values with ASE61850 Test Set, along with our newest product accessory, BNET. This session will be for approximately 45 minutes, followed by Q&A. A few general hygiene points before we start. As this is a large number of participants will be joining this particular webinar, this will be a listen-only session. Of course, if you do have any doubts or queries, please feel free to type in your questions in the chat window during the talk itself. We will try to address them here at the end of the talk or come back to you individually in case we run out of time. All right, so I would now like to introduce our panelists for today's webinar, my colleagues Larry and Sterin. Larry Price is our expert in DNP3 and substation protocols with more than 20 years of experience in the industry and a regular trainer of DNP3 protocol and the ASE2000 test set. Sterin Jose is the lead product manager of ASE61850 tools with again 20 plus years of experience. His areas of expertise are naturally on IEC61850, SEL, and substation protocols, and is also a trainer for IEC 6.0 protocol and the ASE61850 tools. So,
yeah,
hey, let's start. Me start off with asking you, Sterin. Our regular visitors here would know that we usually showcase the ASE2000 or the ASE61850 tools set. So what is the BNET?
Yeah, BNET is an accessory basically for ASE650 test set. So currently, if you look at it, ASE650 test set supports MMS and Goose. Basically, it covers all the station bus functionalities. But right now, it doesn't support the process bus functionality or the sample value. With BNET, it will be an accessory to ASE650 test set so that it can support sample value. So that's the primary goal of BNET hardware.
So I come from a background where DNP3 is prevalent, Modbus, other protocols in North America using the ASE2000 test set. Why haven't we incorporated any of the 61850 features into the BCOM unit accessory that goes with the ASE2000 test set?
So mainly the processing requirement of process bus is on a higher side compared to any other station bus protocol. So if you look at it that way, mainly because of the processing requirement. So we have a separate hardware which is highly capable in BNET, and that will do most of the processing of the process bus function and hand over the data to ASE650 test set. So that way the processing is distributed between the laptop or the computer and the BNET. So that's the idea.
Okay, Sterling, you had mentioned about process bus. So for maybe some of the new folks out there like me, can you elaborate what exactly is a process bus?
So earlier, the CTPT signals were wired directly to the relays, protection relays, and with the 61850, they are trying to digitize that part, right? So here, by process bus, we mean the communication from the CTPT, like current transformer, voltage transformer, and all to the relay. So that part has been digitized, and there will be a separate network that connects from this CTPT to the relays. So we are referring to like process bus to that network.
All right, okay, got it.
Darren, can you please share with us what will be covered in today's webinar?
So today's webinar will be a kind of introduction to BNET. It is mainly for existing and new 650 users. And basically it tries to explain how 650 test set can help them in testing process bus network in addition to station bus network. So that's, I think, looks like the industry demands kind of digitization across the board, and without process bus, some of the testing capabilities of 650 test set cannot be utilized. So that's the whole idea to cover today.
All right. Well, how is the current market maturity for an upgrade to IEC 61850?
From recent event participations, we're seeing more and more utilities and existing customers starting digital substation pilots using IEC 61850 and process bus. And this is an indication that IEC 61850 is being introduced into the North American market.
That's good. That's good to hear.
And Larry, can you explain about the hardware to the audience so that they know what all capabilities comes with it, like from a hardware perspective?
Certainly. The BNET hardware is a little slightly larger than the existing BCOM. The dimensions are roughly 6 inches by 6 inches by 2.5 inches. As you can see on the upper left image, there are two GigE Ethernet ports, and there are two SFP fiber ports for process bus sampling and network testing. It's DC powered. It comes with a AC to DC adapter. You have LEDs on indicating activity on that front side. A capture LED, so it will indicate that you're live capturing, and a PTP indication to ensure that you have a reliable time sync source present. On the upper right hand side, you'll see a 2PC port. It might be slightly hazy in this image. It's a USB port, C style, and then you have another USB port. Those two ports are used or for future feature, so they're not yet incorporated into the present version. Well, they're incorporated, but they're not active ports. The one gives you an option to use a USB to connect directly to your computer so that you can utilize those other ports for testing purposes. And the other is for connection to an SSD drive so that you can log, store data. You also have channel activity LEDs on there. You've got the error LEDs per the ports. We label our ports A, B, C, and D respectively. And we also have standard indicators for communication, TXRX LEDs on the bottom half. And then also you'll see the capture LED there, the PTP indication when you have an active connection to your time source. And then a general status LED and drive presence indicator. And then your other standard LEDs are power, and then you have a maintenance LED that indicates that the BNET accessory is detecting connection to your 61850 test set application, which is incredibly beneficial during test time. And we've got another slide that'll show a comparison with the BNET and the existing ASE 2000 BCOM unit. So roughly 6.5 by 6.5 by 2.5. As I said, it's compact. It easily fits inside a bag or a small case, and it's not much larger than what we have for the BCOM, but a much more powerful processor inside.
And looks quite portable. And I also see that there is, I mean, you spoke about the SFP ports. So, what's the need for an SFP port instead of making those as a default Ethernet or fiber option?
So the SFP port allows you to connect either to a fiber port or a Ethernet port, right? So nowadays switches comes in different forms. They also mostly support SFP ports. So if the process bus supports fiber optic, then you will have to connect these ports to a fiber connection. So that way, so here you get the flexibility of using any of these, right? You can have a SFP connector with Ethernet or SFP connector with fiber optic. So by default, the unit comes with the fiber optic SFP connectors.
All right.
So in previous webinars, we've demonstrated the 61850 test set. How do we connect and access the information from the BNET with the 61850 test set?
So at this point, maybe it's a good time to switch to 650 test set and show the actual functionality. So here, uh, from a test set perspective, you need to enable the port that you are going to use. So here, for example, here by default it is connected to the Wi-Fi adapter, right? So I'll switch to the network adapter. I have a USB to Ethernet connector, so I'll switch to that so that test set will use that port for the scanning function. So once you do this, and if you go to the BNET setting, right, you can scan the BNET. So if the BNET and your laptop are in the same subnet, so let us see how it behaves now. So if they are in the same network, it will try to automatically connect there. So here you can see that the first channel, right, channel A, it's in the same network as PC, and it is able to make the connection. So you will see the star here to indicate that this BNET has been connected through this channel A. And channel B is also active, but it is connected to kind of a separate network. So that's what you see here. But imagine you don't have a connection, physical connection to the BNET, or especially you have the physical connection, but you don't have kind of same subnet IPs configured in laptop and BNET. So these are the other two scenarios that will happen. So we can also see how that works in such cases. So I am removing the connection to the BNET on the BNET side. So if you do that and try to scan, basically it will not be able to find the BNET in the network, right? So it will tell you that there is no BNET in the network. So it will search for some time and you'll see that there is no BNET in the network. And the other scenario that I would like to show is BNET and testset are in the different network. So I have connected the BNET to the port 3 or channel C. So that means BNET is in a different network at this point. So let us see how that scenario works. So here you can see that test set could identify that BNET has a different IP range. So here it tried to make a connection to 192.168.3.121, but test set is not in that same range, right? So it says that it cannot connect. So here you will have to kind of, if you want to connect BNET to the same port, then you'll have to make laptop and BNET to the same IP range. But let us go back to the same port A. Okay, so now I will scan once again so that it can connect to the port number 1. So yeah, this way you will be able to discover the BNET from the network, even though laptop and BNET are in different IP ranges. So that's an advantage. Uh, and here you will be able to manage the IP address and subnet and gateway of all these ports. You can configure them. You can set all these functionalities here. And other thing that you can do is set the BNET time. So here, right now, the BNET is not connected to the internet and it don't have a time server access. So that's why you see it as failed. Right now, it is configured as NTP. And you have an option to switch to the PTP. If you have it, you can sync it with computer, PTP, and NTP. So these are some of the options you will have, and if it detects the proper signal, it will show it as okay. But right now, as I mentioned earlier, it doesn't have the NTP or PTP signal available in the network, so will not see that. And finally, we have a firmware update feature. BNET serial number can be viewed from here, and it will also show you the date when the firmware was released. So this firmware came with the latest release of test set. We had 2.1 release in March. So this firmware came with that 2.1 release, and you can verify that here. And here you will be able to update the firmware to get the new features. Say, for example, if you upgrade your test set, and then test set will have a new firmware available, and you will be able to update that firmware to the BNET. So these are some basic maintenance features that you will notice.
Sterin,
So
you mentioned about the. Sorry, Larry, please go ahead.
will the test set notify users that there's a new firmware available?
Yeah, that's right. So that means when you come to the screen and if there is a new firmware available, it will indicate to the user. So test set will check the BNET and try to match the firmware that it has, because all the functionalities on the test set can be kind of synchronized to the BNET, right? So it will try to kind of synchronize it, and it will ask user to upgrade it if there is any new firmware available. That's right.
Sterin, I had a couple of questions with regards to the PTP, right? So what are the PTP profiles supported? And I mean, also, I mean, a generic question like, why do we have PTP in addition to NTP as a time sync option?
Yeah, the process bus communication in general depends highly on time synchronization, and it's not only the time sync part, it is the very high accuracy of time sync is required for the process bus, because all the processes packets or sample value packets doesn't carry the timestamp by default in most of the cases. So there is a sample count parameter that is shared, um, but because of that, all the devices in the network is expected to have a kind of very accurate time source, and so that everybody is in the same page with respect to the time. So that's why the PTP is the ideal option for the process bus. But we have provided NTP as a additional option in case PTP is not available. But recommendation is to have PTP for the process bus.
All right. We had also one additional question from the audience. So, what are the port speeds? So, I think they're mentioning about the fiber. Sorry. So, they were asking on the port speeds for the product.
Okay. Yeah, all the ports are gigabit. So yeah, so that means all the ports are capable of handling traffic from process bus.
All right. Yeah. So, I think the next I think would be probably about showcasing how the BNET handles the publishing and subscription of sample values. Right? So, probably we can show how that's done.
Yeah, sure. So here I can, yeah, we can start the configuration. So to show the publishing and subscription, we will have to switch to the server mode. In client mode, generally, the test set only allows the monitoring side of it. So to demonstrate both the functionality, we will switch to the server mode and show you from the. Okay, so now we are switching into the server mode, and you can see the BNET status from here. It's connected, and it is connected through the USB based gigabit connector. And now we'll go through this normal process where we browse the ICD file. I have a sample ICD file with both like SV functionality and other MMS models. So I'll select that. In this case, since we are using the process, we don't need the IP address. So I'll go ahead and select this device here. If you expand, since we are primarily interested in the SV or sample value, go to this area. If you are interested to see other 6150 models, you can browse the logical devices here. And then further, since we are trying to configure the simulation part of SV, then you may drag and drop these sample value control blocks into the publisher pane. So you will notice a SMB publisher pane here. So it will allow you to kind of drag and drop any publishers from sample value, and it will initialize those sample values for the publishing side of it. But if you are interested to monitor the sample value, you will do the same thing. You don't have to simulate the sample value to monitor it. These are independent functions. They don't have any relation to each other. So because of that, you will have to separately drag and drop the monitor side of it. So here I am dragging and dropping all the sample value control blocks to the monitor part. So in a typical scenario, you will not use this kind of capability. You will either use it as a sub publisher to send some sample value out, and you might be monitoring some other sample value from the network, right? That's the typical scenario. You may not you publish and monitor the same signal, but for the demonstration purpose, I am just using it that way. So that's the configuration part of it. Now, the next part I will show is the actual publishing of sample value in the network. So here you will notice the start and stop column, and here there's a play button, and you will be able to click that play button and start the sample value publishing. We kept it separate because in some cases you want to stop and start sample value streams based on your needs, right? So that's why you have separate buttons for doing this. And here you have other columns indicating the IED name, logical device name, sample value control block name here, then dataset. We also have the SVID listed here, and there is also a SIM bit. And if you go to the IED node, and you will be able to control whether the simulation bit is enabled or not. So by setting this either to true or false, you will be able to control the functionality here. You also have the SMP sync. This will indicate whether the BNET is time synchronized to the network or not. And here you will see the general status of the publishing. And we have same functionality on the other side. Here you will see all the information as coming from the network. So to start the demo, I will run the publishing, and you will see a few events here saying that the publishing has started. Right now you can see that these sample value streams are being published with the 0 values. If you don't specify any value, then it will give some kind of, I'll give some dummy values for currents, and also set the phase angle, some ranges, and also set the phase say voltage, and angle for phase B. These are some sample values, not really in the actual network. So yeah, here, since we have kind of set up the publisher with all the RMS values, the BNET will convert these RMS values into sine waves internally and apply it. So here, if you notice the monitor, right? Yeah, so here, if you start, you can see that the subscription is enabled with the zero values. It is showing all these zeros, right? Now, if you enable these values, basically apply the values, then you can see that it is coming on the uh, subscriber side. So this is how we are kind of handling that part. So this is the general, just clear the simulation. There are several simulations that I have set up. So I'll stop the simulation so that we can go to the next part.
Sterling, I'm just I'm looking at the questions from the audience. Please keep those coming in, by the way. This one
Okay.
with regards to the SMB publishing. So, what's the maximum limit for number of SME publishing? And follow-up question on that is, do you have plans to increase them in the future?
Yeah, so from that perspective, currently we are recommending 4 sample value streams. We are not blocking a user from adding more sample value streams, but recommendation is to use like 4 at this point. But yeah, over the period of time, as BNET kind of improve the capabilities, we kind of add more sample value streams capability to it and recommend that number.
All right. Great. Yeah, so beyond this, what are the other capabilities of the BNET?
Yeah, BNET provides you several options to kind of manage the simulation part and the subscription part. So here, if you notice, there is if you go to the tools and properties, you will see SMB subscriber settings and SMB publisher settings. So these options will allow you to kind of control the simulation part and subscriptions. For example, here you can let us go to the publisher part first. So by default, the publisher will be running in normal mode, but you can configure the publisher to run with a delay simulation. So once you set the delay, then the packet delay will be applied. So for example, here you can see that the packet delay of 100 microsecond will be applied, and it will introduce this delay. If you select the delay part, it will introduce this delay in every thousand packets. So this is the frequency of introducing that simulation, and this is the actual delay of the packet. And if you have chosen the skip packet simulation part, then you can specify how many number of packets to be skipped each time. Uh, and you can also specify when should be the first delay to be introduced or first skip to be introduced. So using these properties, you can basically control all the parameters on the publisher side. So this will allow you to test the network in specific fashion. For example, if you are anticipating that the packet delay in a network will be so and so, then you can simulate that parameter here and see how the IEDs will behave. And similarly, you can also find out how the relays will kind of respond to the skipped packets. If you are seeing a few packets missed in the network, which normally doesn't happen, but in the worst case, if you want to simulate that scenario and see how the relays and devices response, you can utilize these capabilities. And here you can also force the sample sync status, that is time sync status can be kind of set here.
So that means, I
And
mean, you can simulate the missing packets, right? And also reordering, duplication, packet corruption.
we won't be able to simulate the reordering and packet corruption at this point. Right now, we only support the delayed and missed packets.
Got it.
Okay.
Darren, can you expand that properties window for our participants so they could see the window?
Sure, definitely. Yeah, these are other properties which are already available in test set. There are several properties for maintaining the connection. This will be more applicable to the client mode of operations. And here you can see other properties for the user interface. And we have some properties specifically for the server simulation functions and the exchanges. So, and we have some general settings for BNET. For example, you need to set the nominal frequency for the BNET. Here it is set as 60, and some other properties to control the BNET connectivity and all. So these are some other features we have.
So there's quite a few options to custom tailor your simulation and environment. Are you planning to
Yeah.
show all those capabilities in today's webinar?
Today we'll be primarily focusing on the RMS value changes and angle value changes because that's kind of a straightforward option to simulate. And here, yeah, we can also see the packet delay threshold, and you'll see how much time is consumed for each of these demo areas, and we can basically kind of go from the if we have more time, like we need to allocate some time for the question answers towards the end, right? As we see more questions during the webinar, we'll see how much time we have, and based on that we can plan. But at least we will kind of cover the RMS value changes and delay detection in this demo. Okay.
Sterin, you mentioned about you mentioned that it can handle up to 4 sample value streams at a time, right? Is that correct?
Yeah, that's right. So earlier we saw only one, but at a time it can do 4. So we can see that we can demonstrate 4 sample values. So maybe we can do that. First, we will see the RMS value changes and then expand that kind of to 4, right? So let us do that. So here, I think in the first demo, we did not do that, right? So we'll try to show the RMS value change detection, clear the history because we had a delay detection configured. And here, one of the pane that you will be interested is to see the delay statistics. So it will show the real-time delay of all the packets. So here you can see that minimum delay of the packet is in the range of 13 or 14 millisecond. And here you have the maximum delay. In some cases, it's going from like the range of 100 microsecond, and average delay you can see that it is in the range of 30 microseconds. So this is the average number. So if you want to put some kind of specific threshold values, you can configure it in this property here. If you browse to the packet delay threshold, so here if you configure and if any packets go beyond that, then it will indicate that as an event here, something like error in the network. And here, as you see here, like you have all these values here. Now let us make a significant change in this current value and apply it. So now you can see that this RMS is introduced, RMS change is introduced in the publisher side, and we should see the event here as well. So here, if you look at it, you can see that the RMS value change from 11 to 17 is indicated here. So using this way, you can identify whether there is any drastic change in RMS values. You can configure the dead band for the RMS changes. So here, if you look at it, the dead band percentage for voltage and current is available. We also have phase angle dead band for these parameters. So using these, you will be able to set it. So for example, here, imagine we are having a change in the current phase angle, and yeah, looks like it is not crossing the threshold. So we will have to make it slightly higher, I think. Yeah, so here it is crossing the dead band of the threshold. So that's why it is indicated as a event. So you can see all these. Yeah, here also, yeah, this one also was detected actually. So So all these parameters can be fine-tuned to give you an idea of which all events are happening in the network. That's kind of functionality we have. And then now we can also see the delay simulation and detection. So here, now let us go to the BNET setting. Sorry, we need to go to the tools and properties. So here you may simulate a packet delay of say 120 microsecond, for example, and then you may set it as delay. So here you are instructing BNET to simulate a delay of 120 microsecond and also kind of simulate that delay at a frequency of 1000 packets. So that means this it will introduce a delay of 125 microsecond in every 1000 packet. That's what it is and for. And here you may specify a delay threshold of say 120 so that it will detect this 125 delay. So if you apply this, this will be immediately applied to the network, and you can see that it is it's delayed here, right? So here I will stop the disable the simulation so that doesn't. Yeah, so now I have disabled the delay packet detection. So if you notice, you can see that yeah. So here you might have noticed that there is a separate parameter that will allow you to control the simulation. So for example, here, if you go to the publisher, there are there is a number of packets that need this simulation to be applied, right? So that's why it is doing it on 1000, the packet number 1000, and further it is, and here you have a parameter to specify which packet should have this simulation. So here you have specified as 1000. So 1000 is the first time when you will see this simulation applied, and then you have two packets with that simulation. So here you can see that it is the delay duration detected is approximately 150 microsecond. There is a overhead of 25 microsecond approximately from a network perspective. And you can see that this simulation is applied every 1000 packets. So that means after 1001, then the simulation is applied in the next packet at 2000 and 3000 and so on. So the two packets are simulated with this delay or skipped. So this, yeah, you can control the simulation in a very fine-grained manner. You can do all this here. Yeah, these are some kind of advanced features, and we can also simulate the missed packets since we have time. I think we have approximately 20 more minutes. So I will configure the missed packet scenario as well. So let us go back to the skip, and now we can change this a little bit. Say we can simulate the skip packet scenario in every 1100 packets and make the 4 packets missed in this case. Okay, so we'll keep other parameters same. So if you do this, then here you can see that the missed packet threshold is 1. So that means even after missing 1 packet, the BNET will recognize it. Okay, now let us apply this change. And now if we look at the subscriber, right, it is basically identifying all these. So now we'll go back and disable the simulation so that doesn't cause too many simulations and entries here. Okay, so now coming back to this missed packet, you can see that here 4 packets are missed from packet number 1000. This is a sample count, and here from 1000 to 1003 we instructed it to simulate the missed packet scenario for the 4, right? So it is doing that, and the next packet, it is introducing the missed packet scenario is 2100, because here we have instructed it to do that in every 1100 packets. So it's following that instruction and simulating those scenarios. So yeah, you have the option to control all these properties in this test set. And coming back to Midhun's original question on simulating the number of streams, right? So here you can do the same for all 4 streams. So let us enable all the 4. So once you select one row, basically you are kind of filtering events for that row, and yeah, that way you are seeing the events for only that sample value stream. And I can start the monitoring of those signals. You can see that in the publisher side, if you notice the second stream, we don't have any simulation here. So just dummy values to indicate that it is being received on the other side. Yeah, you can see that it's immediately reflected. And further, we can do the same for the third stream. So here you can see that the RMS value is currently 0, and now we shall switch to that and set the phase B value to some random number and see that it is getting reflected properly, and we can do the same thing for the fourth sample value stream. So respective of the number of streams in the network, you can kind of easily monitor up to 4, which will be increased based on the fine tuning of the firmware in future. So we can simulate a voltage here and see that reflected here immediately. So yeah, this is kind of basic functions that we have.
Right. There was one question. Can this test set be opened offline? Is it required to review or arrange setup which basically set up which SV from the SED to simulate? So the question
Yeah, you
was,
will be able to. Yeah, you'll be able to configure the test set in offline mode. That means you can monitor, basically load the CL file. You will be able to configure the point list, goose, reports, exchanges. This is an automated environment where we can control the test and also the SV monitor and publisher. But yeah, definitely the real-time simulation and monitoring cannot be done in offline mode. Yeah, looks like we covered most of the features here, right? Like we covered the missed packet scenario, delayed packet scenario. I think it's yeah. Okay. So is there any other questions from the audience that we need to address? Harry, is there any other points that you
I saw a
see?
couple other, I believe. So
yeah,
there was a question from Miguel. Madun, I'll let you narrate.
yeah. So yeah, a few questions. So one is, does it support contract playback? So that is one.
Yeah, this was one request we received from some other utilities as well. So yeah, currently contract playback is not available, and we are capturing the signals in the BNET right now. It is stored, but currently we don't have a playback feature. We will have the playback feature soon in our one of the future releases. So, and we will also have the full network capture capability coming up in one of the future releases. So these are some features planned on the roadmap.
All right. And a few other support questions. Phase of visualization, PRP and HSR. I think that's probably discussed.
Yeah, the PRP and HSR is one of the intended feature of BNET. Right now, it's not enabled, but as you can see, the physical hardware, you can have the PRP functionality enabled using these ports. So yeah, in future, it will be enabled and will be available, but it will be like a future firmware update.
All right. And how many IEDs or tags can be supervised or subscribed to? What's the what's the number of IEDs?
Okay, so we don't have a limitation from number of tags perspective, but test set is primarily used for troubleshooting purposes. So from that perspective, kind of we expect user to load, say, kind of in the range of 10 IEDs in the test set and troubleshoot that, simulate or troubleshoot that environment. For the full simulation, we'll have to depend on the IED Smart tool. ASE61850 IED Smart comes as a simulation tool for the entire substation, and there you will be able to simulate larger number of IEDs. But we don't have sample value functionality there. It's only kind of GOES and MMS capabilities can be simulated. So sample value can only be done through BNET.
Understood.
It looks like he answered that other question, Midun. So what are the upcoming BNET features planned for release?
We have several features planned. One main feature is kind of fine tuning the BNET and increasing the number of streams capability. That's one thing planned. And the other capability planned is having the full network capture and capture it in offline for the future analysis. So these are the two main features that we are planning in the short term. Yeah, so at this point, yeah, these are the things that we can share from a feature perspective. There are many other features planned ahead, but yeah, at this point, won't be able to share the details.
Question I received quite frequently at a recent conference I attended um, is a BNET expensive compared to the standard ASE test set price?
Actually, no. If you look at the price of other process bus products in the market, BNET will be much lesser compared to that. We want all technicians to have the capability to analyze the process bus because if we might switch to the 6150 digital substations, then most of the analysis and troubleshooting that you do in the DNP3 substations will have to be done on 6150 as well, right? So our objective is to kind of enable all the technicians, all the engineers with this capability. That's why it is a very portable device. It's a lightweight portable device that you can hook it into the laptop and process bus network and do the troubleshooting. So that's the objective. And because of that, it is not expensive compared to other products in the market. And right now, if you see, there is a ongoing offer of 30% discount. So for a short duration, you will be able to avail that discount and get peanut at a very competitive price.
And touching once again on new features, how frequently will users get these new features? What's the schedule look like?
We have releases in every 4 to 6 months. That's a typical time frame. So 6 months is the maximum, and 4 months is kind of a very short interval. So yeah, in the past we have been focusing on BNET release, and this release was delayed a little bit, but we always try to stick to that 4 to 6 months schedule. So yeah, that's the time frame. You will have new features available.
As we get new feedback and additional feedback from our customers uh, requesting, new functionality, um, what kind of support will we have for that?
Yeah, if any utility or customer want a new feature, then they can contact our support or sales and request that. And if that is going to be available in a roadmap, in a short roadmap, then that will be available kind of in the next release. But if you are looking for a slightly different feature than the roadmap feature, then we have a services division who will use the BNET and test set as a framework, and provide the additional functionalities implemented for you. That's the model we have. Like yeah, any short-term roadmap feature you will have, you will get it in the next release, and any other uh, kind of feature request we'll have to get it implemented by our services division.
Thank you.
Yeah, looks like we covered most of the points, right? Yeah, we are kind of 10 minutes early from the plan schedule. Looks like
Yes,
we will.
yeah, we did receive quite a few number of questions, and many thanks for this interactive session. I have one just question that has come up. Can you simulate typical faults other than over undercurrent and voltage? For example, simulate the SV streams needed to trigger a distance protection fault or differential protection fault under over frequency.
Yeah, right now we don't simulate the frequency, but that is one feature we could add. Definitely, that was one request we had from some other customers as well. So we can simulate, we can add it into a roadmap, but right now we don't simulate complex protections. But yeah, you can always do the current RMS value changes and voltage changes. So that will do like under voltage and over voltage, undercurrent, overcurrent scenarios, right? That's a typical fault you'll see. But complex simulations are not supported, or sequence of events is not supported. But in future, what you will see is kind of exchange enabled for sample value. So that means, as I said earlier, using exchanges, you can sequence the simulation in an automated fashion. So right now, the exchange functionality or the automation function is not integrated with sample value. You will have that feature available in a short term. So then you will be able to sequence the simulations appropriately.
Great. All right. If there's any further questions, please put it out in the Q&A section. I'll be happy to answer that. All right. I think we are good. Great. Thank you so much, Sterren and Larry, for this very interactive session, insightful session. Uh, so, as always, of course, we will be sending you the webinar recording to all the registration. So, you would probably get that mail in 24 hours. If you have any queries or anything, please just send in a mail to marketing@calculate.com, or you can individually email us in our email IDs. So if you have any questions or any queries, please you can send in a mail to that. Great. Okay. So I think we can conclude. Thank you, everyone, once again. Thanks, Steven. Thanks, Larry. Have
Thank
a
you
good
very
day.
much.
Thank you.